Noble gases. They are group 0, which is on the very far right of the periodic table. Helium at the top, then neon, argon, krypton, xenon, and radon. Now, they're group 0. When I was a kid, they called them group 8, but now they call them group 0 because their outer shell has a full set of electrons, which is 8, apart from helium, which has 2, because that's in period 1. So they have a full outer shell, which means they don't react at all. They don't do anything. And there's that magical word that we looked at in electrolysis as well, inert. So the noble gases, the group 0s, that group on the very far right of the periodic table, they are all inert, which means they don't react with anything. Now that group, when I was a kid, was called group 8 because of the 8 electrons. Now we call it group 0 because it doesn't react with anything. And there are helium, neon, argon, krypton, xenon, and radon. So we didn't. These were the last elements that humans discovered. Now the reason that we didn't discover them for a very, very, very long time is because they are inert. They don't react with anything. So there were no experiments in which it would suddenly be discovered because they don't do anything. And also they have no color, so we couldn't see them. So helium is possibly the most famous one. Everybody has inhaled helium and had a squeaky voice. That's not the same for all of those gases, by the way. So helium is less dense than air. So it's not as thick, so it floats as well as making your voice weird. And as you go down the group, the noble gases become thicker, so more dense. This means that boiling points go up, melting points go up, and obviously density goes up as you go down the group. So helium is less dense than air, so it floats. So if you put a helium in a balloon, it'll float up. But if you put like krypton or argon in it, it won't, because these are heavier or more dense than air, so they will sink down. So helium's a bit weird. Hydrogen is also less dense than air. It'll make things float, but it's highly combustible. If you put a flame near hydrogen, it will explode. But helium is inert, so it doesn't do anything at all. So an exam style question, mostly for the noble gases, is to predict missing data. So for example, boiling points, melting points, and density. The answer, you don't have to be exact, you don't have to know the exact number, you just have to make a really good guess and be more or less within the range. So for example, I've made these numbers up, these aren't correct. So you could have like, helium has a boiling point of 38, the next one has a boiling point of 57, the next one has a boiling point of 79, and you have to fill in the gap. Now, if you look at those numbers, which is more of a maths question, you've got 38, 57, 79, so you're probably looking at the late 90s. For the missing one, you could even go to the early hundreds, and all of those answers would be more or less correct. So the missing one would logically be probably, let's say, 99, 100, 105, around there. That would be logical. So there's a lot of pattern prediction with noble gases in the GCSE, and that's the sort of stuff you need to look out for. Thank you.